Okay, so the radius of a hemisphere and the radius of a cylinder are equal, and the hemisphere and cylinders have equal volumes. Calculate the ratio of the height of the cylinder to the radius of the cylinder. So, because we know the R's are equal, radius is equal, and the volumes are equal, we can literally say, look, the volumes here, 2/3 pi r cubed, that's the hemisphere volume, of course. Okay, it's half of a sphere, which is sphere formulas on page 2. And then you've got your cylinder there. Okay, now you've got this. Now, the R's are equal, yeah? They're the same. As I said, that's why we can have them equal. Now, what we can do here, right, we could, because there's pi on both sides, we could divide through by pi, okay? Yeah? Happy with that? So you divide both sides by pi, or you could think about taking that pi over and dividing. It's up to you how you want to see it, okay? So we could even take the whole of that pi r squared over and divide. So watch what happens now. So pi r cubed, take the pi r squared over and divide, and you get that equal to h. The pi's cancel, and then the r cubed divided by r squared. Of course, using indices, you just take the powers away, so you get r. So 2/3 r equals h, right? So that's going to help us now get our ratio. Now, when we see this 2/3 r equals h, that means the radius is actually more than the height, isn't it? You know, if I was to draw this out, sometimes it's helpful to see this visually, okay? So if I was to say draw that out, and that would be my radius, okay, then my height would be slightly less than that, because the height here, h, is 2/3 of what r is. So if you think about r, the radius, in 3 parts, yeah, it's helpful to think 3 parts in this case, right? Because the height is 2/3 of the radius. So if the radius has got 3 parts, the height has got 2 parts, okay? And there effectively is our ratio, right there, 2 to 3. Okay, so the height of the cylinder is 2 to the 3 of the radius. Does that make sense? You can see there how the ratio comes into play. The radius has got 3 parts, the height has got 2 parts. And that's kind of how it works in terms of the ratio relationship. It's quite hard to see it from here, okay? But when you see that 2/3 of the radius is what the height is, okay? Then drawing a little picture maybe will help you see here, of course, that the height is 2/3 of the radius, okay? So it's smaller. And in terms of parts then, well, split the radius up into 3 parts, and you realise then the height is only 2 of those 3. So you can see your ratio then, height has got 2 parts, and the radius has got 3 parts.